So today we're talking about a topic called variation in section 6.8. This is going to conclude our discussion on rational expressions that we've been talking about through chapter 6. And it is an application section, so we're going to be seeing some word problems. Variation is this idea that you have, in the world you have sometimes multiple quantities that change together. Some sort of correlation between them. An example might be the height versus weight of a child. As a child grows in their height, they often also weigh more. So as their height increases, their weight would increase. This is a scenario where the two are related, the two values are related, and they're both changing together. You've seen recently, headlines and stuff on Facebook probably where, the grocery stores are starting to become depleted of goods. And so another example might be the coronavirus. As the coronavirus, I think I'm spelling that right, as the number of cases of coronavirus increases, the toilet paper on shelves is decreasing on the shelves in the store, right? So as the coronavirus increases, the toilet paper on the shelves decreases. So these two things are relating to each other in an opposite way. As one increases, the other decreases. So when the two go in the same direction, either both increasing or both decreasing, we call that direct variation. So both increase or both decrease. Okay. Inverse variation either the first one increases, which causes the second to decrease, or the first one decreases, which causes the other one to increase. So they change in an opposite way. Now, an example of direct variation, one that you've probably seen before, is distance equals rate times time. Okay? We would say in this case that distance varies directly with time. Now, in that equation, in order to get a direct variation, we have to assume a constant rate. So you have to assume the rate isn't changing, right? So if you set your cruise on the highway for 70 miles per hour, this would then be an example of direct variation. All right, so I'll give you an example. Let's say we have a rate that is fixed at 70 miles per hour. Let's just take that example. Then you know that if you were to drive for 1 hour, you would travel 70 miles. And if you drove for 2 hours, you would travel 140 miles. Okay, using this equation, you put a 70 in for the rate, d equals 70t, then you multiply by the time. 70 times 1 is 70, 70 times 2 is 140, and so forth. Okay. Generally speaking, for direct variation, you have a variable we'll call y for the dependent variable, and a variable called x we'll call the independent variable, and some sort of constant multiplier. So for direct variation, you have y equals k times x, or in this case, d equals r times t. R is our constant, k is constant here, where k is a positive constant. Okay, so k has to be positive to get them to be direct variation, and it has to be constant. Okay. Okay, another example, one where you have inverse variation, might be something like the force of gravity versus the distance from an object. Okay, so inverse variation. It's interesting, the force of gravity, as you get closer to an object, a large object like a planet, you feel the force of gravity greater than you would further away. The moon, for instance, doesn't feel the force of gravity of the Earth as much as a person on the surface of the Earth does, because we're closer to it. Okay, so the force of gravity is some constant divided by, in that case, the distance squared, and usually we call it, we'll call it d squared. Okay, it's the square of the distance between the two objects. So we would say that the force varies inversely with the square of the distance. Okay, and so instead of multiplying by the constant, or constant multiplied by the variable, it's a constant divided by that variable. Okay, so for inverse variation. All right, and so inverse variation, generally speaking, will have this relationship where a variable is equal to a constant divided by another variable. Okay, so x and y vary inversely. Again, k has to be your positive constant.